Assalamualaikum and very good morning to Medora Sidabwang, Medora Shah Muhammad and all the viewers. We are P43S21 would like to present our comparative study of Box-Jenkins and GARCH model in forecasting the rainfall in East Coast Malaysia. And this is our supervisor, Madam NORLIANA binti MOHD.LIP.
Hi, I am presenter 1 and my name is SOFHIA.
Hi, I am presenter 2 and my name is NURUL AQILLAH.
Hi, I am presenter 3 and my name is NURUL NASUHA. This is our presentation outline. Abstract. General statement. Rainfall is important in daily life either for agriculture, industrial expansion or the survivals of people. Problem. Mismanagement and lack of forecasting rainfall will lead to natural disasters such as flood. Objective. To identify the best selected model in forecasting rainfall in East Coast Malaysia. The methodology is Box-Jenkins and GARCH model. The results are linked to the same site, which is GARCH as the best selected model. Conclusion. In forecasting graph shows a slowly decreasing pattern of average rainfall for Kelantan, Terengganu and Pahang in 2021. Background of study. In general, studying a region's weather and climatic elements are critical for the long-term growth of agriculture and planning. Rainfall forecasts are commonly utilized in the flash flood warning process. The main focus of this study is to determine the relevant and best model from this approach and predict the amount of rainfall using the best selected model. Problem statement. Heavy rainfall in East Coast Malaysia often lead to natural disasters such as flood. First objective, to identify the pattern of monthly rainfall in East Coast Malaysia. Second, to evaluate the rainfall data performance between Box-Jenkins and GARCH model. Third, to focus the future value of monthly rainfall. The significance of this study, it can focus the rainfall data in East Coast Malaysia. Box-Jenkins, which is ARMA model, has been widely used over the years to predict the rainfall trend. GARCH is a computational data that can be used to analyze a wide range of financial data. Scope of this study. Data collection are obtained from dataportal.AISHAH website. The software that will be used to analyze the data is EViews 11.
ARMA is one of the methods under the Box-Jenkins methodology. It is encompassed the whole modeling approach for each series. And GARCH model, known as a non-linear generalization, is another line of study in time series that stem from Box-Jenkins model. In this research, the researcher will look at 3 types of error measurement, which are MSE, RMSE, and MAPE. After identifying the forecasting approach with the lowest error measure value, the best model will be utilized to predict future value.
Next, let's continue with the literature review on summary of this rainfall analysis. Based on the table above, a higher percentage of East Coast Malaysia will lead to flooding, such as Kota Baru has been detected as it floods almost every year. Forecasting rainfall is very important in order to give yearly warnings, so that Box-Jenkins and GARCH model will be used as a method in this study. The table above indicates the summary of Box-Jenkins model is widely used in forecasting rainfall and defined as the most successful technique for evaluating the time series data. As you can see, the Box-Jenkins method is widely used in many different areas, such as the gold and food industry for flood prediction and during a pandemic of COVID-19. Let's continue with GARCH model. Excessive distribution and the precipitation phase achieved by GARCH family models. SARIMA and GARCH was applied to eliminate the conditional variance of the SARIMA model of precipitation time series in 2 different climatic environments. The application of GARCH model can be used in many various fields, such as a rainfall prediction, forecasting gold price, forecasting inflation and network traffic. By doing a combination between GARCH and other methods is the way to get accurate results.
Following is data description. We are using secondary data of daily projected rainfall by state in Peninsular Malaysia from 2016 until 2020. The total of number of average rainfall in each state in Peninsular Malaysia, which is in Kelantan, Terengganu and Pahang, are shown in the graph above. Research activities methodologies. We will discuss each phase of the methodology as shown. The first phase is data collection and data cleaning. The second phase is for the research method. In this step, I'll be explaining the detail in the next part. Back to the framework, the third phase is by performing evaluation and comparison, and lastly, prediction of rainfall data in East Coast Malaysia. In research method, we have to set the equation for both of ARMA and GARCH model and then run the data in EViews. Here is the comparison in step making for ARMA and GARCH model in order to obtain the best model. The significant difference between the 2 models is in performing diagnostic. That is the certainty of the best model before proceeding to perform the error measure. For ARMA, check the diagnostic by adjunct statistic and then check for estimated ARMA process is covariance stationary and it is invertible. Meanwhile, for GARCH, there will be 3 types of GARCH model error construct, which is normal distribution, student T, and GED. For each of the error construct, there will be a few tests before proceeding to the next step. Continuous on that, here is the formula for error measure. We have mean squared error, root mean squared error, and mean absolute percentage error.
The selection of the best model is taken from the 5 parameters that have been chosen for each state. The above show the equation and the criteria of the best selection model in Kelantan, which is ARMA 2.1 because it has the smallest value of AIC, BIC and Dubin-Watson near to 2 compared to other models. And this is also the equation of criteria of the best selection model for Terengganu, which is ARMA 1.2 because it also has the smallest value of AIC, BIC and Dubin-Watson near to 2 compared to other models. The equation of ARMA 2.1 as follows. For Pahang, the criteria of ARMA 2.1 is the best model that most closely meets the criteria compared to other models because it has the smallest value of AIC and Dubin-Watson also near to 2. Next, for GARCH model, the selection of the best model is taken from the 3 or 4 parameters that have been chosen for each state. The above also show the equation and criteria of the best selection model in Kelantan, which is GARCH 1.1 that has the smallest value of AIC, BIC and Dubin-Watson also near to 2 compared to other models. This is the summary of the diagnostic testing in Kelantan. Regarding to this table, we choose the criteria which are the highest value of low likelihood and adjusted as square and the lowest value of AIC. Hence, regarding to all criteria, the normal distribution model is the most perfect to choose. The equation of GARCH 2.1 as follows. For Terengganu, the criteria for GARCH 2.1 is the best model that most closely meets the criteria compared to other models because it has the smallest value of AIC and BIC. Regarding to this table, we also choose the same criteria which are the highest value of low likelihood and adjusted as square and the lowest value of AIC. Hence, regarding to all criteria, the student t-test model is the most perfect for Terengganu. And this is also the equation of Pahang. The best model is GARCH 1.3 because it also has the smallest value of AIC, BIC and Dubin-Watson also near to 2 compared to other models. Regarding to this table, we also choose the same criteria which are the highest value of low likelihood and adjusted as square and the lowest value of AIC. Hence, regarding to all criteria, the normal distribution model is the most perfect for Pahang. This section, I will show the result comparison of error measure and rainfall forecast in 3 states. According to result in the table above, GARCH 1.1 is the best model since it gives the lowest value of MSE and RMSE in the forecast, the future value of monthly rainfall in Kelantan. This is the graph of rainfall forecast in Kelantan for GARCH 1.1. It shows that a slowly decreasing pattern from January until December 2021 because heavy rains and floods in certain places at Kelantan rarely occur every month. For Terengganu, GARCH 2.1 is the best model since it gives the lowest value of MSE and RMSE in forecasting the future value. And this is the graph of rainfall forecast in Terengganu for GARCH 2.1. The decreasing pattern can be seen for the first quarter of the year and it slowly shows the straight line until the fourth quarter of the year. According to the result in the table above, GARCH 1.3 is the best model since it gives the lowest value of MSE and RMSE in the forecast the future value of monthly rainfall in Pahang. And lastly, the graph below show of rainfall forecast in Terengganu for GARCH 1.3. Forecast graph show a curve from maximum to minimum value and slowly decreasing pattern from January until December 2021.
Conclusion. In the study we run each states individually, then it clearly shows no trend for the 3 states. Hence, objective 1 achieved. Between ARMA and GARCH model, the best selected method will be selected using the lowest value of error measure as more accurate forecasting value will be. Thus, the result are lead to the same site, which is GARCH as the best selected method. Hence, objective 2 achieved. In forecasting graph using GARCH as the best selected method, it shows a slowly decreasing pattern of average rainfall for Kelantan, Terengganu and Pahang in 2021.
For recommendation, this study can be useful for future researchers, since there are not many studies done by other researchers regarding comparing Box-Jenkins and GARCH method. This study also can be a helpful tool for other researchers to forecast rainfall in other areas using non-seasonal data. Autocorrelation function also can become a potential method.
This is the list of reference that we are using throughout the research. That's all from us. Thank you for listening.